Hello, in this video I'm going to explain 2017 paper 3 question 2. This looks like a standard collision problem. Let's get started. Part A. For the time during the collision, suggest and explain whether both trolleys could be stationary at the same time. Well, that depends on whether this would be a violation of PCOM, yeah? Let's calculate the initial total momentum before the collision, and it turns out to be negative 1.29 Newton per second. So I'm taking rightward to be positive. That's why trolley's B's velocity, which is a leftward velocity, has to be represented by negative 2.2. So it turns out the net momentum is a negative, so it's a leftward momentum. By the principle of conservation of momentum, the total momentum before, during, and after the collision must be exactly equals to negative 1.29 Newton per second. If both of them have the velocity of 0 meter per second at the same time, that means at that instant, the total momentum will be 0, which is different from this. That will be a violation of PCOM, so it's not possible for both of them to come to rest at the same time. So how do we verbalize all this? First, you should show the calculation that the total initial momentum before the collision is not 0. And then you explain that if both of them were to come to rest at the same time, that means total momentum must change to 0, and that is a violation of PCOM. Alright, let's move on to the next part. Part A2. Calculate the average force between the trolleys. Now remember, force is the rate of change of momentum. So to calculate the force between the two trolleys, we can either calculate the force experienced by trolley A or the force experienced by trolley B. But we are going to go with trolley A because for trolley A, we already know the final and initial velocities. And the calculation goes like this. So the force, which is applied for 0.3 seconds, provides this impulse, which changes the momentum of trolley A. And the change of momentum is simply its mass times the change in velocity. So what we put here should be the final velocity minus the initial velocity. Final velocity is a leftward 0.7, that's why it's a negative 0.7. Minus away the initial velocity. The initial velocity is a rightward velocity, so minus a positive 0.9. So it turns out the force is negative 8.0 newtons. The negative sign here makes sense because it's a leftward force, right? I'm taking rightward as positive. Okay, let's move on to the next part. Part B1. Use the answer to the earlier parts to calculate the speed of trolley B after the collision. So we are going to apply the same calculation, but this time to trolley B. Because trolley B experiences this force F, which we know now is 8 newtons, applied for 0.3 seconds. So this, the impulse, is going to change the momentum of trolley B by this much. It's always advisable to just assume that the final velocity is a rightward velocity, a positive velocity. So the change in velocity would just be a positive VF minus a negative 2.2. Do the math, final velocity turns out to be negative 0.20 meter per second. The negative sign here is actually telling us that the trolley B is still moving leftward, yeah, after the collision. And in fact, that's what the next part is asking us to explain. Part B2, use your answer to explain the direction of the motion of trolley B. So we're going to say that it is a leftward velocity. How do we know? Because we are taking rightward to be positive while using the sign convention of rightward to be positive. So when we get a negative number, it means a leftward velocity. Okay, we've come to the last part of the question. By considering quantitatively, that means we have to perform calculations, yeah? So by considering quantitatively the RSOA and RSOS of the two trolleys, deduce whether the collision is elastic or inelastic. We just have to check whether the relative speed of approach is equals to the relative speed of separation, which means we have to check whether this minus that is equals to that minus this. So RSOA is 0.9 minus negative 2.2. Negative 2.2 because it's a leftward velocity. Relative speed of separation will be negative 0.02 minus negative 0.7 because both these velocities are leftward. If it's a elastic collision, then RSOA should be equal to RSOS, but obviously they are different. So our conclusion, since the relative speed of separation is smaller than the relative speed of approach, collision is inelastic. And so we have completed question 2. If you have any questions, just leave them in the comment section. Ta-ta!